Hello all, and thank you for visiting the channel. We are MZ Automation, a specialized team dedicated to the design, implementation, and integration of communication protocols for embedded systems. Today, we will be giving a quick introduction to the IEC 60870 test client. The IEC 60870 test client is a powerful and easy-to-use tool for testing, monitoring, and analyzing devices and software that implement the IEC 60870-5101 and IEC 60870-5104 protocols. It supports both CS101 serial and CS104 TCP/IP communication, enables users to send standard and custom messages, tests commands, analyzes telegrams, transfers files, and secures communication with TLS encryption. The client also allows recorded telegrams and the latest values to be exported for further analysis. Before establishing a connection with the server, open the connection menu and select Connection Parameters. This dialog contains all the settings required to configure communication with the IEC server. First, select the protocol mode. You can choose CS104 for TCP/IP communication or CS101 in either unbalanced or balanced mode for serial communication. Depending on the selected protocol, you'll see protocol-specific communication settings. When CS101 is selected, the dialog displays the serial communication settings. In the link layer address section, select the address size used by the connected device, which can be 0, 1, or 2 bytes. The default slave address specifies the link layer address of the slave device used when sending messages. In balanced mode, you can also configure the own address, which identifies this client on the link layer. The Serial Parameters section allows you to select the serial interface and configure the baud rate and parity settings. These values must match the configuration of the connected device. You can also configure the poll user data interval, which defines how frequently the client polls the device for new data. When using balanced mode, the DIR bit option is also available if required by your communication setup. For CS104, the APCI section allows you to configure the K and W acknowledgement parameters. The K value specifies the maximum number of unconfirmed I format messages that can be transmitted before waiting for acknowledgement. W defines after how many received messages an acknowledgement is sent. The timeout section contains the communication timers T0, T1, T2, and T3, which control the connection establishment, acknowledgement timing, retransmissions, and idle connection supervision. In the application layer section, select the size of the common address, or CA, and the information object address, or IOA, according to the configuration of the connected device. The Cause of Transmission section allows you to include an originator address, which is used by some devices to identify the source of commands. If secure communication is required, enable TLS and open the Settings dialog to configure the security parameters. You can also specify a local network interface by enabling the option and entering the local IP address and port to be used for the connection. At any time, click Set Defaults to restore the recommended default configuration, OK to save your changes, or Cancel to close the dialog without applying them. For the next part of this demonstration, we will be using a CS104 connection. First, enter the IP address or host name of the server in the IP/hostname field, followed by the port number. The port must match the one configured on the server. Before attempting to connect, make sure the server is already running and ready to accept incoming connections. Once the connection settings have been entered, click Connect to establish communication. When the connection is successful, the client is ready to communicate with the server. After the connection is established, The Telegrams window will appear and display all communication exchanged between the client and the server in real time. At the top of the list, the client sends a Start DT Act message to start data transfer, and the server responds with a Start DT Con, confirming the connection is active. The server then begins sending process data as IEC 60870-5104 telegrams. Each entry shows important information such as the message type, cause of transmission, originator address, common address, information object address, value, timestamp, and quality information. In this example, periodic measurement values are being received, indicated by the cause of transmission periodic. The sequence numbers shown in the APCI column help monitor message acknowledgement and communication integrity. A little later, the client sends a general interrogation command. The server acknowledges the request and responds by transmitting the current state of all configured information points, including measurements and status indications. The Telegram view provides a detailed and chronological record of all protocol activity, making it easy to verify communication, troubleshoot problems, and analyze device behavior. Thank you for watching this video. For more details on our products and services, visit us at www.mzautomation.de. Don't forget to like and subscribe to stay updated. See you there!